Today's topic is about polymerization. The term polymerization means when we convert the small molecules to a long chain compound or to a large molecule. In short, I'm writing small molecule to large molecule. This process is known as polymerization. And this polymerization is divided into two categories. One is known as addition polymerization, and another one is condensation polymerization. So what happened in addition polymerization? In addition polymerization, when small unsaturated, they should be small and unsaturated. The term unsaturated is used when there is a carbon-carbon double bond. So when small and unsaturated monomers join to form the polymer as one product, so small and unsaturated monomers join to form the long chain compound as a product, we call that as addition polymer. Only one product is there. But what happened? So what happened in condensation polymerization? In condensation polymerization, is small molecules such as carboxylic acid, alcohol, and amines join to form polymer, and the term condensation here refers to water. So condensation polymerization is having two products. One is the polymer itself and another one is the water molecule. Sometime hydrochloric acid in A levels you will learn hydrochloric acid, some reactions polymer is formed in condensation polymerization. But for O levels you just have to learn that a polymer and a water molecule is there as a product of condensation polymerization. And which type of molecule can undergo condensation polymerization? Carboxylic acid, alcohol, and amines. These are the three molecules which can undergo a condensation polymerization. And what cases, because which one will react? A condensation polymer will form when amine will react with carboxylic acid. It can form when carboxylic acid is reacting with alcohol. How it is formed, that we will discuss. But these are the three combinations when alcohol mixed with another alcohol. These are the three cases in which a condensation polymer can form. And the product, when they will react, it will form a polymer plus water. And this polymer plus water will be there for when carboxylic acid react with alcohol, there will be polymer and water. And when alcohol react with another alcohol, there will be polymer and water. And this condensation polymerization is divided into two categories. Condensation polymer can be a man-made or synthetic, or it can be natural. There are many synthetic polymer, like example, in our everyday life we are using lot of polymers, like a bucket of water, that's also a polymer. A plastic bag which we are using, that's also a polymer. Even a plug, a socket, a holder, these all are made up of long chain hydrocarbon or polymers. There are a lot of polymers, but you have to learn only two of them. So two of the synthetic polymer or a man-made polymer formed by condensation polymerization. One is nylon. How to identify a polymer? If it's a long chain compound, very big molecule, we call that as a polymer. Like you cannot write an end for this, it's a continuation. Nylon and polyester, these are synthetic polymer. Natural polymers, condensation polymers such as protein, carbohydrates, and fat. So these are the natural polymers, condensation polymers, which are formed by condensation polymerization. So a polymer is a long chain compound. It can be formed by two ways. It can be formed by addition. Addition means when alkene is a monomer, like you have alkene molecules, that we discuss about addition. You have many alkene molecules, they join together. This is a monomer. But when any alkene molecule join together and form a long chain compound, and continuation repetition is there in the structure, that long chain compound is known as polymer. Because we have only one product here, so we call this polymerization as addition polymerization. But what is the meaning of condensation polymerization? It happens when a polymer plus a water molecule is also given off. And it can happen when amine react with carboxylic acid react with alcohol, and alcohol react with another alcohol. What about alcohol and amine? Like why I did not write the other combination? Alcohol and amine does not react. So if they don't react, they cannot form a polymer. The reactions are only possible when amine with carboxylic acid with alcohol, and alcohol with alcohol. Other reactions are not possible. And naturally, these are addition is always synthetic. Addition polymerization is always synthetic. But condensation can be synthetic. Addition is always synthetic, but condensation can be synthetic. But condensation can be synthetic or it can be natural. So the condensation polymerization, in which a polymer and a water molecule is given off, can be man-made or synthetic. or it can be natural. Synthetic, you have to learn about nylon or polyester. Polyester, or you can also say polyester or styrene. And natural, protein, carbohydrates, or fat. Now first, the formation of synthetic polymer or formation of a nylon. The important thing is they will give you the monomers and you have to draw the structure of the polymer. Synthetic means man-made. The synthetic means what we are making, and natural means by nature there is also a reaction, a polymerization reaction, which result in this protein, carbohydrate, and fats. The first one is formation of the nylon. Formation of the nylon. What are the monomers? Means the molecule which react. The monomers are diamine and dicarboxylic acid. The molecules which will join together, one is known as diamine, another one is known as dicarboxylic acid. What is the structure of a diamine? The term di means two, and the term amine refers to when nitrogen and hydrogen they have a bond. This is called amine. And carboxylic acid, C double bonded with O and OH. C double bonded with O and OH, that is called carboxylic acid. So the monomers here are diamine and dicarboxylic acid. What is the meaning or what is the structure? The term di here refers to two. So we have two amine groups, but where these two amine groups are attached, so these two amine groups are attached at the ends. So when I draw the amine means NH2. So nitrogen forming a bond with hydrogen, that's a amine group. And then there is another amine group because it's diamine. So there is another amine group, nitrogen form a bond with hydrogen. Now how these amine groups are linked with each other? They are linked by a carbon, like there are carbon atoms between them. But we don't have to bother about how many carbon atoms are there, because that will not do any difference to the formation of a polymer. So instead of drawing this, instead of writing how many, maybe some have 6 carbon, some have 12 carbon. So different number of carbon atoms are there. Normally it is 6 carbon. But instead of drawing those carbon, what we can do, we can just make a box here. What is the meaning of this box? This box means that there are carbon atoms, but instead of drawing the carbon atoms, we are just representing by a box. Is it clear? This is diamine. Is it clear the structure of the diamine? The term di means two and amine means NH2. So it is having nitrogen, NH2 group both sides. That's why we call diamine. And between them there is a carbon chain, and this carbon chain may vary in number. So that's not a fixed number. That's why instead of drawing all the carbon atoms, we are just using a symbolic representation, a rectangular box. Then what about dicarboxylic acid? So di means two and carboxylic. So what is a carboxylic group? When I draw a carboxylic, So C double bonded with O and OH. So we have two carboxylic groups, C double bonded with O, O and H. And there's another carboxylic group, C double bonded with O, O and H. And between them there are carbon atoms. But because there are a lot of carbon atoms, it's a big molecule. So instead of drawing all the carbon atom, what we can do, we can also use a symbolic representation. If they have the same number of carbon atoms, we will use the same symbol. If the number of the carbon atoms in the one molecule, the first molecule is same as the other, we can use the same symbol. Otherwise, you can use this as a shade. So what it shows, this is also showing that there are carbon atoms between them, and this molecule is known as dicarboxylic acid. Why it is called a dicarboxylic acid? Because there are two carboxylic groups. So two carboxylic groups are there. The first one diamine, the second one dicarboxylic acid. What happened in this polymerization? Because to form a polymer, to link them together, they should release water. So how they will release water? So amines, these amine group will lose their H, and carboxylic will lose its OH. Amine will lose its H and carboxylic will lose its OH. So what it result when they will form a polymer, H and OH being removed? So when H and OH being removed, the hydrogen is removed. This will be N, H, then there will be a box, then NH. Now this H and OH being removed, so if it is removed, this nitrogen will form a bond with carbon. So this nitrogen will form a bond with carbon, C double bonded with O, and then this is a shaded part, means the carbon chain. Then C double bonded with O, and this OH is being removed, so put a bracket and N. That is a polymer. And what we call this polymer? We call this polymer as nylon. So this is a structure of nylon. And what else will be the product? Because H and OH, so it will produce water molecule. And how many water molecules? You can see H and OH one water molecule and OH and H another. So it will give two water molecules. If N molecules are there, it will give 2N H2O. Two water molecules when two molecules are reacting. But if we have N molecules of this and N molecules of this, how many water molecules will be there? 2N H2O. Is it clear? The formation of a nylon, the structure of the nylon, how nylon is formed. And the bond between this bond, C double bonded with O, and then this bond, what is the name of this bond? This bond is known as amide or peptide linkage. So amide linkage or peptide linkage, this bond is having a name. So in nylon, we have amide or peptide linkage. And this is a polymer. So nylon, like we are using nylon threads, nylon ropes. So actually what is this nylon? This nylon thread or nylon rope is actually a polymer, which is formed when dicarboxylic acid reacted with diamine. Di means two, and amine, because NH2 groups are there, we call that as amine. What is the meaning of 2H2O? Because what happened, as you can see, if you have one molecule of diamine and you have one molecule of carboxylic acid, one side there is H, another side OH. So that is one water molecule. One side H, another side OH. So it will give two water molecules. But if you have N molecules of amine and N molecules of dicarboxylic acid, so how many water molecules will be there? It will be 2N H2O. Is it clear? The formation of nylon. The difference between the shaded and the unshaded box is representing the difference between the carbon atoms. If they have different carbon atoms, we use different shades. Like if they were having a same number of carbon atom, we'll use the same shade. Like this is a simple demonstration of formation of a nylon, different ways the nylon can form. So what we are doing, we are mixing diamines, both are in a liquid state, with dicarboxylic acid. So when we mix them together, this is the formation of a nylon. So nylon is formed between the layer of the two solutions, and that we can remove as a thread, like a string. And then these strings are woven and make a stronger nylon. Is it clear? The formation of this nylon, which is diamine and dicarboxylic acid. Then the second type of a polymer is known as formation of tyrrolene or polyester, or tyrrolene. So how a polyester or tyrrolene is formed? Why we put 2NH2O? Look, if you have one molecule of diamine and you have one molecule of dicarboxylic acid, how many water molecules they are forming? One side H and OH, that is one water molecule. Another H and OH, that will be second water molecule. So two water molecules are there. But normally you don't have, you have lot of molecules. So example, you have N molecules of diamine and you have N molecules of dicarboxylic acid. So how many water molecule will be released? That will be twice multiplied by number of the molecule. So 2N H2O, where N is a number of the molecule, which can be any number. Practically, you don't have one molecule, you have millions or trillions of molecules which form a long chain compound. Then formation of polyester or tyrrolene, the monomers, are dicarboxylic acid and diol. So what is the meaning of dicarboxylic acid? the term dicarboxylic acid means 2-carboxylic acid at the end. So if we draw dicarboxylic acid, it will be C double bonded with O, ONH. That is one carboxylic acid, and this is another carboxylic acid. And between them, they are linked with a carbon chain, which are having lot of carbon atoms. So we can use a symbolic representation. And the structure of alcohols, diols, di means two, and ol is for alcohol. So OH groups are there, two OH groups, we call them as diol. And between them, there's a carbon chain. It may have a same number of carbon or it may have a different number of carbon. So we can use a different symbol. So this one is dicarboxylic acid. And this one is diol. Now to form a polymer, polymerization, condensation polymerization, they should react in a manner to release water molecules. So how they react? First, carboxylic acid will lose its carboxylic acid, one side it loses its H. The carboxylic, one side it loses its H and the other side it will lose its OH. Same thing, alcohol, diols, one side it loses its H and the other side it will lose its OH. So the shaded part which is lost now, so what it result, that what we are left with, that will be a polymer. So one side we remove H, so it will be O, C double bonded with O, then there is a box, then C double bonded with O, and this OH and H being removed. If OH and H is being removed, then what we are left with? We are left with oxygen, then this shaded part, this part, and then OH is removed, so put a bracket and N. Plus, how many water molecules are there? H and OH and H and OH. How many water molecules? What will be the total number of the water molecules? So it will be two water molecules, but because if we have N molecule of the first one and N molecule of the second one, it will give 2N H2O. And this is known as a polyester, which is a polymer or terylene. And this bond, C double bonded with O and O, what we call this bond? We find this in ester. So polyester contain ester linkage. So nylon contain the linkage, the bond which is present in a nylon, that is amide. As you can see, this C double bonded with O and N, that's called amide linkage. But the bond which is present in polyester is called ester linkage, and that's why the term ester is there in their name, because they have a ester linkage or ester bond is there. Why OH is removed? This OH is reacting with H of carboxylic acid, and one side OH of carboxylic acid is reacting with H of alcohol. So react in this manner, result in a formation of a polymer. So whether you have to shade this In exam, normally when they give you in exam, they provide, either they write the number of the carbon atoms or they give you the shaded one. So if they provide the number of the carbon atom, you will write the carbon atom. So that will be given in the exam. You don't have to learn whether how many carbon atoms are there or whether they are same or different. The monomers, normally the monomers are given and you just have to complete a structure to draw a polymer. Is it clear to everyone, the formation of a polyester? So two synthetic polymers are there. One is nylon, and there are more, but you have to learn two. And the second one is polyester. Polyester clothing, maybe you have seen, like this is how the polyester, this is what polyester look like. These are all polyesters. So example, if I say the monomer is given, this is a monomer, and you have to draw the structure of the polymer. CH2 bracket 6 NH, and then C double bonded with O, OH, CH2 bracket 4, and C double bonded with O and OH. Now the monomers are given. If the question is draw the polymer, so how to draw a polymer? First thing, you should identify the monomer. You should know what are the monomer. It means, because two amine groups are there, so this is diamine. Two carboxylic groups are there, so at the end, so dicarboxylic. So when diamine react with dicarboxylic acid, what it result? Which polymer is formed? Nylon or polyester? What will be the result? The polymer which is formed by the reaction of dicarboxylic acid and diamine. So this will form nylon. Now to form a nylon, what you do? Just remove hydrogen. Yeah, nylon plus water will be the final product. So what you will do? You will remove hydrogen from amine and remove OH from carboxylic, both sides, and just complete the structure or draw the same structure without H and OH. So it will be N, H, H and OH both should be removed because it is forming a water. One side if you remove H, the other will remove OH to form a water. That's how the water is formed in a condensation polymerization. So NH is there. Then you have the CH2 bracket 6, means 6 carbon atoms are there. Then NH, this H and OH being removed. So you have C double bonded with O, and then CH2 4 C double bonded with O, and OH is removed, so put a bracket N plus how many water molecules are there? 2N H2O. So carboxylic acid, when reacting with amine, they lose their both OH to react, and amine will lose their H to form a condensation polymer, which we called nylon. So this is a nylon, and it is having an amide or peptide linkage. Is it clear? This is how we draw the structure of polymer, a synthetic polymer. Same way, if you want to draw a polymer, if the question is draw the polymer, For when dicarboxylic acid is reacting with diol, so C double bonded with O, ONH, and between them there are carbon. Like example, this is CH2 bracket 2, and this one is CH2 bracket 8. So this is 2 carboxylic, so dicarboxylic, and this one is diol. So when dicarboxylic acid react with diol, what it result? It will result in formation of polyester and polyester and water. And it's up to you, if one side you remove H, it's up to you. If one side you remove H, other side OH. One side H, other side OH. And complete the structure for the polymer. So it will be O, C double bonded with O, then CH2 bracket 2, then C double bonded with O, H and OH being removed, so O, then CH2. So the reason here, what is there between the functional groups does not affect the polymer. That's why we can use a symbolic representation and put N plus 2 N water molecules will be there. So this is a polymer which is known as polyester because it is having a ester linkage. So these are the two synthetic polymers you have to learn. Any question related to synthetic polymerization? The second session I will explain the natural polymers which are formed by condensation.